Hello everyone, my name is Josh and welcome to today's video on vectors. Now, apologies if you can hear the rain in the background. I live in Manchester, there's not a lot I can do about it. Today I'm going to be talking about vectors. So in maths, vectors are quantities which have both a value and a direction. We call it magnitude and direction. So a normal quantity would be called a scalar, or a distance. So say for example, when you are taking the perimeter of a triangle, one of these lengths, A, would be a scalar because it has no direction associated with it, it just has a value, say A equals 5. But the difference with vectors is that, say if I construct a triangle out of vectors, these have direction on them. So it's a key difference because it means that you don't necessarily just add them up to get the perimeter. So say here you've got A. So this has a magnitude and a direction. So say for example, this arrow is moving 1 unit to the right and say 3 units down. So that means that 1 unit to the right would be like that, and 3 units down would be -3 like that. So this is the direction of this vector. We define x, so it's just like a coordinate. So in a normal coordinate, you'd state it like that for x and y. But for this vector, because we're saying it's moving 1 to the right, that's +1 in the x direction. And because it's moving 3 down, we say it's got -3 in the y direction. And so we write it just the same way that we'd write a difference in coordinates. So this is the direction of a vector. And for the magnitude of a vector, what we do is square and add these units. So we use our good old Pythagoras, and we use 1 squared plus -3 squared, all square rooted, is the magnitude of A. That's how we write magnitude. It's also important to note that, so for vectors, you want to underline them to indicate they are vectors. Or you can do it as, if you're doing it as a distance, you can do it as like this format. If you're doing the distance between points O and A, like this. So the magnitude of a vector, you just add its components and square them. So in this case, it would be 1 squared plus 9 square rooted, which is √10. And that is what we call the magnitude of this vector. So our conventions when it comes to measuring vectors, a vector that's moving in the right direction, we define it as having a positive x change. A vector that's moving in the left direction, we define as having a negative x change. Similarly, a vector moving in the positive y direction, up like that, plus y change, and down like that as -y change. So this is all important information when it comes to defining vectors. Because say, for example, we have this vector, and it's moving 1, 2, 3. So these will all be on grids for you, but I don't have grid paper, so I'm just using these dots to show what they are. So here, the change in x is 3, and the change in y is 1, 2, 3. So that means that 3, 3, so our vector here, A equals 3, 3, like that. So if we get this same vector, but this time it's going in the opposite direction, so the same vector is the same, but the arrows are going the other way. We'll just draw those dots in there. So this time we're still getting a change in 3 here. We're still getting a change in 3 here. But this vector b, we'll call it, b is now -3, -3. Because it's moving in the opposite direction, and that means the values are the same, but the direction is different. And so we can say here, we see that a is 3, 3, b is -3, -3. So a equals -b. Because they have the same magnitude, so we can say they're equal, they just have different directions. Because both of these would have the same magnitude of 3 squared plus 3 squared square rooted, which would be root 18, which would be 3 root 2. That's just splitting that up into root 9, root 2, and then root 9 is 3. So both of those have magnitude 3 root 2, but have opposite directions. So that's all you really need to know of basic vector theory. You should know more than that based on your lessons, but I'm mostly going to talk about an example question with vectors because I find it's more useful once you understand the theory. So moving on, we will do a question on vectors. So in this question, we're given this parallelogram. Now just pretend the lines are all straight, I just can't draw. So we can see from this diagram and information we're given, the vector A is equal to the distance OA, and the vector B is equal to the distance OC. We are also told in the question that the midpoint of BC is M, so this is the middle of this line here at M. So we also know that ON to NB is the ratio 2 to 1. So that means 2/3 of the way across is point N, and then you've got 1/3 there. So this is just all important information to know. I'll also write down that M equals half BC, like that. Okay, so that's all the information we're given in the question. Now there's a few different things this question wants us to calculate. So the first thing we're going to try and calculate is the distance ON in terms of the vectors A and B. So this is how we find it in the simplest form. So we want to find ON in the terms of A and B. So ON is this distance just here. So in order to find ON, what we know is this is 2/3 of the distance OB. So ON is equal to 2/3 times the distance OB. Now OB we can make up, if we do, O to A, which is the vector A, and then A to B, which is the vector B. So the distance OB in total is A plus B. So we know that is equal to 2/3 A plus B. And that is just the answer. Because we've got this distance OB here. If we take 2/3 of that whole distance, we get 2/3 up A and 2/3 up B. We end up at N. So that's just how you solve to this distance, because we know that it's just 2/3 of the way across from this ratio we're given here. So that is the value of ON. The next one we will cover, 2. That distance we want to find is OM. So we want the distance OM. So in order to get to OM, we can see that it's the distance OC plus CM. So OM is equal to OC plus CM. Now we need to figure out what OC and CM are in terms of A and B to solve this. So OC is just equal to B. It's one of the definitions we're given at the start. So that's equal to B plus, now C to M is half the distance C to B. Now we know that the distance C to B is equal to A. So C to M is equal to half of C to B. So that means here we've got half of C to B. Now half of C to B is just half of A, because OA is equal to CB. So that means that half of OA is equal to half of CB. And so substituting that in, you get half A is the distance CM. So that is equal to B plus half A. And that's our final answer. So B plus 1/2 A. The next one we will go through is the distance AM. Let's pretend that's an M. AM, like that. So we want to go from here to here. So AM is the distance we want to find next. So we can see that AM is equal to AO plus OC plus CM. So those are the distances. We just go A to O, that's AO, O to C, and then C to M. So we've got to figure out what each of these distances is. So AO, that is this distance this way. Now that is equal to minus A, because A is defined in the direction OA. So AO is equal to minus OA, and that is equal to minus A. So the next one, we want to get distance OC. Well, the distance OC is just defined as B. So that is plus B. Put that back in there. And the last one that we want to get is C to M. Now we've already worked out what C to M is. It's half of C to B, and it's equal to half of A, because it's just half this distance up here, which is half of this distance. So this is plus 1/2 A. Let's put that back in there. So we can simplify this. So what we get at the end is B minus 1/2 A. And that's our final answer. Now, a good way to check these is just see if that seems reasonable. Like, there's no proper official check you can use to check that you've done this right. But you can do it in terms of logic. So if you went from A and you go the distance B, that takes you over to this B here. Now if you subtract half of A from that, that will get you to here. So the way you can check it like that is just by tracing along the shape till you get to the point where it should stop. So for example, if I'd got it the wrong way around and got half A minus B, well, half A would take me up here off the shape, and then minus B would take me over here. So I'm nowhere near where I'm supposed to be. So these figures aren't often drawn to scale, so it may not come out exactly looking right, but if you just try and trace with the rough shapes and sizes of A and B, you'll see whether you're at least in the right area. So always make sure that following the path that you've written, you end up somewhere on the shape near the point that you want. So you can do the same thing for OM here. So from O, you go distance B, that's here, plus 1/2 A, that's here. So we're at the right place. So that's questions where you're supposed to just find a distance between 2 points. The other type of question you might get involves, well, we still want this diagram. So what I'll do is I'll copy this page and I'll paste it onto here. Delete that. So we still want this diagram, so I've just pasted this page over, and I'll take out this previous work and leave it on the last page. So we still want that information as well. So the next question we want to do is to prove points A, N, and M all lie on a straight line. So you may look at this to start with and think, oh well, how do I do that? That's quite a strange looking question. So to prove this, all we need to do is show that the distance AM is a multiple of AN. So what this means is, if AM is a multiple of AN, that means timesing AN by something will give us AM. And that means that the vectors are parallel to each other, because for two vectors to be a multiple of each other, it means that they're in exactly the same direction, just different lengths. So say, for example, this is A, this is N, and this is M. If we said, for example, this isn't the answer to the question, this is just an example, that AN is halfway through AM, that means that AM equals 2AN, because it's halfway across this. So to get from AN to AM, you times AN by 2. So that's what this means, and it's how we show that this is a straight line across here. So now we'll do this with actual numbers, so just remember that this is not the solution. We'll put our actual numbers in here. So we want to show that AM is a multiple of AN. So what we want to do in order to show that these all lie on the same line, first of all, we want to figure out what AN is. So what is this distance AN? So in order to find AN, we know that we can split it up into AO plus ON. So AO is just minus A. And ON, we worked out in the previous question. A lot of the times it will get you to do this. It will make you work out something that you need in the next part of the question when it's a question like this. So ON we worked out here as 2/3 A plus B. So that means we get minus A plus 2/3 A plus B. Now this simplifies to, so you've got minus A plus 2/3 A, so that's minus 1/3 A plus 2/3 B. So that's what we get for AN. Now we want to show that AN is a multiple of AM. So we also worked out previously that AM is equal to, let's go back and have a look, AM is equal to B minus 1/2 A. So this is minus 1/2 A plus B. So we need to show that those are multiples of each other. So the easiest way to show this is to trial it with the easiest variable. So the A looks quite difficult to try and show they're the same. So what we will do is do the B's. So we need to go from 2/3 B to B. So that means we need to multiply an by something to get am. So to go from 2/3 B to B, we need to times by 3/2, because 3 will cancel out with that 3, and that 2 will cancel out with that 2. So that means the B coefficients will cancel out to just B. So if we try this, 3/2 an equals am. Well, we'll also, so that the way we've shown that is 2/3 B times 3/2 cancels out like that, and that is equal to B. So it works for the B coefficient. And now we want to try it for A. So minus 1/3 A times 3/2. Our 3's cancel out here, so that leaves us with just the minus 1/2 A. And that's what we've got here. So our trial factor of 3/2 has worked, and so an is just 3/2 times am. So we've shown that 3/2 an equals am. Now this is good because what we don't want is an to come out as bigger than am, because we can see from the diagram that am is longer than an is. So that means that we wanted a factor which gave us it to be am to be larger than an, which we've got. So all you want to do when you're working out these is look for the simplest variable to cancel down to what it's supposed to be, and then try that factor on the other one, and you should come out with the same thing if they're on a straight line. So because an is a multiple of am, they lie on a straight line. Because as I mentioned before, it means that the two vectors an and am are parallel. So it means they lie on one long line, am. And that is the way you prove it. It's a little bit complicated. What you need to do to get your head around this is sit down with an example like this and try your best to just work through it and understand each step. So make sure you understand how you're working out your distances, and then once you've got the hang of working out the distance between 2 points in terms of one vector, have a go at a question like this where you've got to prove it's on a straight line. I believe this is as complicated as vectors questions are going to get on your papers. You may be asked to work out a resultant vector from two vectors. So say you've got these two vectors where this is the vector 2, 0, and this is the vector 2, 2. Well, the resultant vector is just the addition of two vectors like this. So the resultant vector here would be 4, 2. Because you just add up the components in each one. So you add the top component, put it there. Add the bottom component, put it there. I've tried to keep this a brief overview on vectors, but if that's left any gaps in your understanding, then contact me and I'll try and explain it a bit better. I'm a little bit pushed for time at the minute, so hence why I've had to just try and make a briefer video. So thank you for watching this video. I hope it's helped. If you still aren't understanding some of this topic, because this topic is quite complicated as far as GCSE topics go, then just contact me and I'll try and help you with individual problems that you're working out, or try and make another video on this if a lot of people find that they're not getting it. If you have any other topics you'd like me to cover, just let me know, either through a message or a comment or whatever you would like, and I will make a video on the topic when I get the chance. Thanks again for watching, and I hope to see you next time.